The third presentation will be delivered by Jean-Pierre Cauzac, Strategic Project Manager of CLS. He's going to talk about FishX project supporting the digital transition of small-scale fishing in Europe. He is joining us online from France. The floor is yours.
Good morning, everyone. Can you see my screen right now with the main title FishX project? Okay. Thank you very much to the World Ocean Forum to give us the opportunity to present another European project called FishX. My name is Jean-Pierre Cauzac. I am a strategic project manager in CLS, a French company specialized in fisheries management tools and environmental services. And we will present some results today obtained by the data lab of CLS in the frame of the FishX project. In particular, contribution by Théo Saccaro and Anna Conchon. This project, FishX, actually is concentrating on fisheries, but a part of fisheries which is not well known to anyone. These are the small-scale fisheries. In Europe, they represent a crucial role in the fisheries sector because they represent the majority of active fishing vessels, about 75% of the total European fleet, and half of the total fisheries employment for only a quarter of catches. Small-scale fisheries, they support local communities in Europe, but also in every place of the world. And they maintain local ecological knowledge, which is vital to protect our natural resources and foster a sustainable fisheries management. SSF is known as data poor. It is difficult to collect information from SSF simply because we are talking to people who are not used to play with computers, sensors, automatic systems, etc. So SSF at the moment needs to become more digital, attract younger generations, investors, and contribute to a data collection scheme and data sharing efforts for better management of their resource. This is the reason why we built the FishX project with the European Commission. This project is funded by an innovation fund of 4.5 million euro over 3 years from June 2022 and ending in May next year. The project is led by a group from Germany, Transmartech, and we include 9 partners over Europe. The FishX objective actually is to support a new EU fisheries control regulation which will apply to European fishing vessels without size limit. So this will represent between 60 and 70,000 fishing vessels in the EU under the
Mr. Cauzac, I'm sorry to interrupt you. Could you hear me? Do you hear me okay?
Yes.
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 We kindly ask you to please press the slideshow buttons so that your slide could show only one page per time. Right now, we're seeing, your entire slides on the screen here.
You are not seeing the entire slide, is it?
Right. So if you could please press the slideshow button on the top of your program.
Yes. Can you see the entire slide right now?
No, we still see the entire frame.
Just a minute.
Okay.
You should have told me. So just a minute, huh?
Mm-hmm.
Do you see the entire slide?
There you go.
New EU control?
Right, the control regulation.
Oh. Okay.
Yeah,
excellent.
I think that's perfect. Thank you.
Yeah, sorry for the confusion. Okay, I was saying that we built FishX because there is a new EU regulation coming in Europe that was voted at the end of 2023, and there will be a progressive implementation from 26 to 2030 to require for every single vessel without limit of size to carry a vessel monitoring system, VMS, vessel monitoring system on board, and to use electronic solutions like electronic logbook for reporting their daily activities. On top of that, there are electronic monitoring requirements for fishing vessels above 18 meters in length, which present a high risk of non-compliance with the landing obligation, which is the obligation to land every fish captures. So these vessels will be equipped with cameras. And in addition to this, all seafood imported in Europe will have to be tracked using a traceability system provided by the EU called Catch IT, which tells about the vessel identifier, catching method, catch area before the seafood is actually sold to the European markets. So all these solutions present a big change, in particular for the SSF world, which is not used to digital technologies. So we see actually three major challenges. The first one is the acceptability of fishers. We need to create trust with the fishers, in particular those small-scale fishers which are not so familiar with using GPS trackers, tablets, etc., etc. And they are always afraid of sharing their fishing locations with somebody else. And we need to show them the benefits of sharing information. This data will be used for better stock management. This will be also used for giving value to their seafood products, getting access to more demanding retailer and markets, and also to protect their activities against competitive usages. This was mentioned by Jan Van just before. The blue economy is actually developing over the same limited areas, ocean areas, and the fishers at the moment are in competition to access their fishing grounds with new wind farm projects in many places in Europe, for instance. And they are demanding a proof to show that these particular areas are used for fishing before they install wind farms. The next challenge is about data sharing. We believe that every data collected from fisheries at the moment should not be used only for control, but also should be made available for science, for the market, for developing new usages. And this is made possible using those technologies of data spaces. And the last point is that because we are going to generate a vast amount of data, we need to introduce, where possible, artificial intelligence to make all data processing much faster and much more robust. How does FishX contribute to this? In FishX, we are focusing, as I said, about the small scale and also recreational fisheries. We built a FishX data space where the data can be controlled and managed and shared. And we developed two applications which are giving examples of how fisheries data could be made available to a number of usages. The first application is developed by CLS. It's called the Insight Platform. This is a web portal where we can display different types of data collected from fishing vessels under some control and sovereignty rules. And the second application is a traceability app where we can display and provide information from the fish captured to the end consumers. And this is more and more a market request to know where the fish that we buy is coming from and which method has been used to capture this fish, and whether this method is friendly or less friendly for the environment. About this Insight Platform, this solution is being developed at the moment by CLS. This is an example among other examples of how to use a data space. Remember the picture shown by Jan Wendt just before? The data space is receiving a lot of different data and also is managing to whom this data could be shared with or not shared. In the case of Insight, we are collecting the GPS position of the fishing vessels taking part to the FishX project. In this present example, at the moment, we are testing Insight with a full global AIS data feed, but at the end of the project, we are going to demonstrate only those vessels participating to the FishX project. All data are collected and anonymized. Insight does not display any individual tracks because they could be considered as sensitive by the fishers. So we aggregate these data in statistical squares of different size. Here, we show the cumulative positions in statistical squares. And when we zoom on a particular place on Earth, we are going to see more details. The squares are progressively going from about 1 degree size to 0.025 degree size. So we don't show locations where we have only 1 or 2 vessels, because this could be considered as sensitive by fishers, so we show only aggregated information. Where do we collect this data, and how do we process them using AI? I'm going to tell you. At the moment, we have 3 of the partners in FishX which are involved in establishing contacts with the fishers, with the small-scale fishers over Europe. 2 NGOs, WWF and Siena, and 1 Irish Fisher Association. The WWF offices in Portugal and Croatia, and also the Irish Association, are establishing contacts with voluntary fishers using small-scale fishing boats to be volunteers to test and to contribute to this new project. You will see some examples of installations. All the data is collected and go into the Insight platform after the control through the data space and after anonymization, and it will be processed through this AI algorithm. So we installed over more than 100 fishing vessels, small-scale fishing vessels, those VMS units called NEMO, which are developed by CLS. And this is based on a voluntary partnership with the fishers. So all fishers, they have signed a letter of consent to participate, and they share the data in an anonymous way. Also, the fishers, they receive a very simple app for their smartphone, so they can track their own boat, and they can share their own tracking data with their families, with their friends, if need be. So this NEMO unit is a GPS tracker with hybrid connectivity, which means it reports through satellite or cellular networks. So when the boat is far from the coast, it will use the satellite link, and when the boat is quite close, in a few miles along the coast, it's going to transmit through the cellular network. At the moment, they are set to report every 3 minutes a GPS fix, plus speed and heading of the vessel. So this information will be processed. You will see a few examples. So this NEMO at the moment can be installed quite easily, no cables, and it is powered by a solar panel. So we have done installations with the support of the partners in the south of Portugal. At the moment, we're on boats which are in the range of 6 to 8 meters. Also in Croatia, with quite small boats, using traps and pods, fishing hake or sole or scampi. Also, on the right slide, you can see a buoy, a gray buoy called Naos, which is made to track the fishing gears, just to avoid the loss of these gears at sea. Another example of boat equipped in Ireland. So what do we do with the data? This is where the AI is coming. The analysis of trajectories starts with pre-processing and data cleaning. Then we are looking for two types of information. The first one is the identification of the fishing gear. We want to do that automatically because in the case of small-scale fishing, the boats are quite polyvalent and they change their gear from a day to another or depending on the season. Oops. Then the second stage is the detection of the activity to detect where and when and how long the boat is actually fishing. And this is used to estimate the fishing effort. So the first stage is about pre-processing of data. This is quite specific for fishing vessels because the trajectories are quite complex, the activities are very fast. This is where we need a lot of positions. But also this is generating a lot of data in our systems and servers, so this is important to remove all useless data. The proximity to the coast also creates some ambiguity. We need to remove data which are not useful for detection of fishing. So all data which are where the boats are actually stopping at ports or mooring. We try to identify the start and the end of each individual fishing trip. And this is more complex with small-scale fishing than with industrial fishing vessels because the small-scale boats not always stop in well-known ports. Sometimes they stop near a beach or in a very small port which is not geolocated nor available on databases. So we remove all those positions where the boats are in the port so that we can detect each start and end of fishing trip. Here we go with the artificial intelligence. First, we are going to train some models using the datasets that are collected in the project, which are labelized, so which means that we know what the fishing vessels are doing, what kind of fishing gear they use. This has been declared by the fishers during the installation of their VMS devices. So in that example, we have a series of tracks for dredging vessels, gill netting vessels, traps, and pods. We develop a model for each of these categories of fishing gear. And when we receive a new vessel trajectory, we are going to analyze it, and the best fitting will tell us which is the fishing gear used by this particular vessel. And we do that for every new track. So every day we test the whole set of positions collected by the vessels to detect what are their activity over the day. Then the estimation of the fishing time is also quite complex. We want to estimate the fishing time to derive a fishing effort. So the processing is quite specific for small-scale fishing because the activities, as I said, are quite short. So we need to acquire a lot of positions. On the left view, you see the fishing activity. On the right view, we see the same activity with only 1 hour sampling interval. Actually, you don't see the fishing activity. So this is the reason why we are taking positions every 3 minutes. Another critical point is that the vessel speed is more or less the same when the vessels are transiting and when they are setting their nets in the sea. You see on the first image on the left, the setting phase is more or less equivalent to the transit from the shore. So what we need to do is to wait for the hauling phase when the vessel is hauling the net on board. And this may happen another day. So you see that the positions in this case are much more close to each other because the vessel goes quite at slow speed. So what we do is we need to study each trajectory, detect the hauling activities.
Each time.
Yes?
Yeah. Shorten your presentation. Yeah.
Yeah. and we detect where the oiling is taking place. So on the day number 2, for instance, we can detect oiling, and we are going to look over the previous days if we can detect in the same area the setting of the gear. So between day 1 and day 2, we can compute what is the duration of the gill net staying in water, which is called soaking time, and we derive the fishing effort by multiplying with the net length. To conclude, the FishX Consortium is very motivated to develop a new range of digital services to support the small-scale fishers with their digital transition, which will be mandatory in the next 5 years in the EU. We expect that the fishers will find their interest and benefits, obtaining more visibility and protecting their fishing grounds against competitive usage of the areas. The participation of more than 100 fishers to our trials give us good opportunities to develop and to improve AI tools, exchange with fishers, and also build a confidence, which is important. We are thankful to the NGOs and to the participants, and at the moment we are working on a roadmap for the digital transition of these small-scale fisheries, and we are eager to hear your contributions and suggestions. Thank you very much.